I'm going to briefly introduce our three wonderful panelists now, and we'll let them talk more about themselves and their work. I'm going to start by Sam. Sam Ruben is an innovator, entrepreneur, executive, and a co-founder at Mighty Buildings, a construction technology company based out of Oakland, California, which is using 3D printing, new composite materials, and robotics to sustainably unlock productivity in construction. As part of Mighty Buildings' founding team, Sam has leveraged his expertise working with organizations of all sizes across the public, private, and nonprofit sectors to help them improve their sustainability in terms of people, planet, and profit to guide Mighty Buildings certification and sustainability roadmaps. Bringing his expertise to Mighty Buildings alongside his other team members, Sam is working to help the world build better and turning construction into a tool to fight the climate crisis while building much-needed housing. Hi, Sam, and great to have you here.
Thank you so much. It's an honor to be here and really excited to be among such an illustrious company.
Wonderful.
Let me just share my screen and we'll dive in.
Awesome. Thank you.
All right. So one of the big facets that 3D printing brings is the role that it has to play in really transforming construction as a key tool for a sustainable future. Because that's going to be, as we see more and more climate impacts, that's really going to become a big part of what it means to mainstream a new housing construction technologies. So, as many of you may be aware or may not, the built environment is one of the single largest drivers of the climate crisis, with roughly 40% of all global emissions tied to buildings, about 30% of that from the actual energy use of the buildings or the operational carbon. But there's still about 10 to 11% of that that's also generated by the upfront carbon, or the carbon that goes into those building materials, often referred to as the embodied carbon. And so 3D printing offers new possibilities in changing how we build by bringing new materials in, new technologies, and by inherently being a zero waste production process. And so we're starting to see a rise of it across the world. So we've had, obviously, icons building developments in Texas and Mexico for low-income housing. Appiscore has done some office buildings in Dubai. We've got SQ4D listing a home on Zillow. We've got Branch Technologies doing some really interesting work with non-concrete 3D printing for insulated facades and other work. And then obviously the great work that Alquist and Black Buffalo have been doing with Habitat for Humanity to really unlock productivity and bring affordability into it. So there's a lot of opportunities, but at the same time, this is also the building sector. And so it's a heavily regulated marketplace. And so it's really important that there's also new standards being brought into play, because all too often the building codes are sadly written in blood, and they don't actually get modified and updated until something has gone wrong. And so as a part of this, we've been working closely with UL, Underwriters Laboratories, to develop UL 3401, which is the world's first standard for 3D printing construction and has been added as an adoptable appendix to the International Residential Code. Additionally, the International Code Council, ICC, developed a acceptance criteria 509, originally in partnership with Contour Crafting, but more recently updated for multi-story printing in partnership with Black Buffalo. And so that one's really focused on concrete 3D printing. And so having kind of laid that groundwork and the role that the construction sector plays in the climate crisis, I'm going to talk a bit here about what we're doing at Mighty Buildings, because we're doing things a little bit differently. We're really centering sustainability at the core of what we do, and also approaching 3D printing with unique materials and from the prefabrication space. So we're not doing on-site printing, but we're actually printing panels in our facilities and then assembling those on-site. So one of the cool things about what we're doing is that, too far. Sorry about that. Is that we've developed a unique proprietary material that cures using light. So unlike concrete, it's not about time, temperature, humidity. Our material cures almost instantaneously. Additionally, we've developed the ability to do continuous fiberglass reinforcement, which gives us a strength profile similar to reinforced concrete, but 4 times less weight and 4 times better insulation properties. And so We've initially started with accessory dwelling units, delivering those to people's backyards, and have now transitioned into our longer term vision, which is working directly with builders and developers to deploy units as scale as a part of larger projects. And I'll get into some of the first projects we're doing a little bit later. So I'm going to start with a quick video here, which kind of provides an overview on the Mighty Buildings production process, because the printing is just part of the process. Pause a second while that loads. If it's going to load. There we are.
Great.
At least on my screen. The joys of technology.
Yeah, totally.
And the spiraling circle of death. All right. So what you're seeing here is the Mighty Buildings printing system, which, as you can see, we are able to deposit the material like a standard extrusion method, but then hit it with UV light as it's coming out, which triggers the curing process instantaneously. And as I mentioned, we have the ability to deposit fiberglass reinforcement into the print layers as we're printing, which makes it incredibly strong and allows us to create unique shapes and forms with just by changing the file. And once it's done printing, it then goes to our post-processing cell, where we're able to scan it with laser scanners to ensure it matches the digital file is based off of, but then also to create a digital model of the physical object itself to allow us to mill it with tool, because even though our material is really strong, it's still soft enough that it can be milled using CNC heads normally used for metals. And so what this means is that it allows us to leverage that to create exact tolerances for on-site assembly, as well as allowing us to introduce new shapes and forms on the surface. So we can leave it with the raw print, or we can mill it to a smooth stone-like finish. And we haven't done this yet, but there's no reason we couldn't leverage that to make it look like brickwork or make it look like siding. Additionally, we have developed the ability to automate the pouring of foam insulation into the interior of each cavity, and that adds into the energy efficiency of it, which allows us to deploy zero net energy homes. We've also are developing the ability to automate spray coatings, so paints, primers, stuccos that further add to the aesthetic versatility of our production process. And so, in case the video was a little choppy there, these give you a sense of the printing and the scanning that we're able to do. And then this gives you kind of a sense of the actual pouring of it. And one of the things that's really cool is that normally when you're using a high density spray foam like this, you have to have a press in order to ensure that the material doesn't break from the internal pressure. Because of the strength of our material, we don't need to. We're actually able to inject that foam and allow that to expand without any issues. So that's one of the things that we're really, really excited about. Additionally, with the fiber reinforcement, we're able to fully impregnate it. So it becomes a continuous part of the material. And because it's a continuous fiber, it adds significant tensile and flexural strength, which is particularly important for markets like California, which are faced with lots of seismic activity. It also is important for markets that we're moving into, such as the Caribbean and Florida, where we need to be able to address significant wind speeds, up to 190 miles per hour or more, in order to be resilient in the face of hurricanes and other significant severe weather that we're seeing more and more of. And so it's just another view of the robotic foaming. So we've developed the ability to pour the foam. Oh, way too fast. To pour the foam and then put a press on it so that it doesn't come out the top and adds to the pressure there. Also, we're able to optimize the structural capacity and are working on moving from the single-story homes that we've been deploying into multi-story single family, as well as multifamily townhouses and eventually low-rise apartment buildings. So really looking to expand the typologies possible with 3D printing in order to meet the needs of various communities and both do new developments as well as opportunities for suburban and urban infill. And so in terms of sustainability, one of the things that we've done is that we've committed to being carbon neutral by 2028 without the use of purchasing offsets. And so that's something we're actively moving towards as we move down our roadmap. And then Also, one of the exciting things about the 3D printing is the ability to do parametric designs and new possibilities and new forms and shapes, and really unlock what a house can look like and really unlock the creativity of architects. And when we think about sustainability, we're looking both at the operational carbon, which is one of the key aspects of a new development we recently broke ground on in Southern California, which is the world's first 3D printed zero net energy community. We're doing it in partnership with the Polari Group, and it was designed by EYRC Architects and engineered by Burl Happold Engineering, and will incorporate the Delos Darwin system, which is a healthy home system, as well as on-site rooftop solar and battery storage. And then additionally, when we look at our units and look at our material, we're looking at the entire life cycle. So we're really looking to expand what's possible, and that includes end of life. So currently, we're able to recycle grind our material up and recycle it, and add it in new filler, or as filler in new material, up to between 5 to 10%. But as we're actively moving down our embodied carbon roadmap to achieve carbon neutrality and then move into carbon negativity, we're actively exploring the possibilities around true circularity, both in terms of the ability to recycle our material back into a printable form, so product level circularity, but then also looking at what it means to do as systems level circularity or industrial ecology. So the ability to take waste streams from other processes, use those as inputs for our material, something we're already doing with recycled glass and other recycled content in our material, as well as the ability to then end of life break our material down into various components that can be inputs into other industrial processes. And so that's something we're really excited about in Mighty Buildings, and really looking to unlock that opportunity to address both the operational and the embodied carbon, and really help turn construction from a driver of the climate crisis into a solution, while also creating homes that are resilient in the face of the impacts of the climate crises, which we're already seeing and which will only continue to get worse, even if we were to stop all production of carbon today, just because of the feedback loops that are already present in nature. We're going to be seeing continuing impacts. And so we've done hurricane impact testing. I wish I had the video, but it's pretty amazing to see a 2x4 launched at 100 miles an hour bounce off your wall, which was very exciting to see. And so we're really excited for what the future holds. As I mentioned, along with what we're doing here in California, we're in the process of expanding internationally, the Caribbean, Asia, Europe, and are quickly moving towards having a global network of facilities, because our vision isn't to produce in one location and ship everywhere, but rather to actually establish localized production facilities utilizing a microfactory concept that we've developed, where in a small footprint, roughly 50 by 50 square feet, we're able to generate enough panels for 100 homes a year. And so that means we can set up an existing warehouse space near where the demand is, in order to not only be able to produce homes for those markets, but also be able to produce new jobs for those markets, and hopefully attract a new generation of workers into the industry by giving them a chance to work with the latest and cutting edge technology in a safe, controlled environment. Additionally, it allows the possibility of quickly expanding production volume, because if there's greater demand, we just add additional production cells, again, able to be in an existing warehouse. And so that's something that we're really excited about, and we'll begin deploying in 2023. We'll be there when we deploy our first Mighty factory with one of our local developer partners. And so that's not only does that add to the economic development and the ability to localize that supply chain and take advantage of local economics in those communities, but it also allows us to reduce logistical costs, as well as the carbon impacts of transport and all those other added impacts. And because we're doing prefab, we can print 24 hours a day. We don't have to worry about noise issues or setting up, taking down. We don't have to worry about environmental shifts throughout the day that require tweaking of the formula. And so we're really kind of approaching things differently, but excited to have Zach and Lau on this as well, because frankly, the crisis is to the point where it's all solutions on deck. And so really excited to be here with you all, and looking forward to answering more of your questions after the next presentations.
Thank you so much, Sam. Beautiful projects, very exciting, super interesting what you guys are working on. So we already have a number of questions for you, but we will hear the presentations from our, if it's okay, and we will address all the questions. Hopefully we'll have enough time. Thanks again. So our next speaker is Zach. So I'm going again to briefly introduce him and let him talk more about his work. Zachary, so in 2020, Zach, along with his partner, created Atlas Community Studios, a placemaking and economic development group working in 25 plus states. Zach founded Alquist 3D at the same time in order to solve the rural housing crisis. Alquist 3D is printing affordable housing across the nation, starting with the first owner-occupied 3D home in the world in Virginia. Zach is an opinion contributor for The Hill, and his work has been written about in the New York Times, Washington Post, CNN, NBC News, and many other prestigious publications. Zach loves exploring rural communities, producing new pieces of theater, creating restaurant concepts, and has an unhealthy passion for the Philadelphia Eagles. Hi, Zach, and thank you so much for joining us today.
Hi there. It's a pleasure to be here. It's really great to be here with really wonderful colleagues. Sam, that was a great presentation. My name is Zach Manheimer. I'm the CEO and founder of Alquist 3D. Yes, I have an unhealthy passion for the Philadelphia Eagles, but we're not here to talk about that. I'm going to share my screen here and start our presentation. So what I'm going to talk about is the community of tomorrow. And really a lot of what I'm going to cover, Sam was also just talking about. And it's really wonderful to see so many other groups doing this work and are pioneering this process. We've learned a lot from seeing their work as well. But our inherent belief is that rural America is the next place to innovate. This is where our focus is, on smaller communities around the country. And we believe this because if there's any interesting trend that's really happened over the last couple of years, and it's this trend of pandemic migration, of people leaving bigger places and wanting to go to smaller places. And obviously, many of those smaller places are rural. And we see article after article after article come out about this all the time. There's people writing about this every single day. And really, when we get to a point where Spokane, Washington is too expensive, we know that we're in trouble. And here's some data that just came out a couple of weeks ago. There was another article yesterday in the Wall Street Journal as well about this, is how major cities lost population in 2021. And that's the first time in a long time that's ever happened. And skyrocketing housing costs are one of the contributors to this. So this is nothing new. For the past 50 years, the coasts of our country have been oversaturated and people have been leaving. This map really illustrates the rural loss over the last several decades. It's been really dramatic for where they've been going. And our congressional map shows it. People are leaving the Northeast, they're going south and they're going west. And here's a map of where they went between 2000 and 2007. They largely went to what we call second cities: Minneapolis, Kansas City, Nashville, Austin, Denver, Miami, New Orleans, Atlanta, Phoenix. Those are the cities that gained population at almost identical rates as a place like San Francisco did per capita 100 years ago. Very similar patterns. And we used to say before the pandemic, by about 2030, those third cities would be oversaturated. And that's where we're in the rise of now, is places like Des Moines, Iowa, Boise, Idaho, Albuquerque, New Mexico, Little Rock, Arkansas, Birmingham, Alabama, Madison, Wisconsin. These are the cities gaining population today. And we used to say by 2030, that's when these third cities would be oversaturated, but everything has changed. Remote work has been obviously a strong driver of why that's happening. I'm obviously broadcasting this from my basement right now. I was remote working way before it was cool. But what's happening now is there's this three-headed migration monster that's attacking the country. It's economic migration, which has been happening for decades. It's pandemic migration, and climate-based migration, because people don't want to be living around where there's significant storms all the time. So you add all these pieces up, and we believe there's about 15 million Americans looking for new places to live, work, and play. And so the process has changed. We believe there's no more rhyme and reason for where people are going to go based on population and location. And we think that people are moving right now. They're going to be deciding by about 2024 where they're going to locate. And for the first time in human history, people don't have to be attached to a large major city to experience the best arts and culture, the best education, and the best business opportunities. You can do it anywhere, but that presupposes that your community has very strong broadband and you have a high quality home to live in. So those are the major issues that we have to focus on. So we're looking at rural largely because of this migration shift, but also because we believe this is the next place to innovate. And when you talk about a rural community, they don't have the luxury of focusing on one of these issues over another. They have to attack all of these problems at once. And that's the work we've been doing for years, way before we got into 3D. But housing is at the base. It doesn't matter how great your community is unless you have a home to live in. So if we see this opportunity, we need to be taking advantage of it. If we're going to repopulate, we need some new homes. So here's the basic problem. Every time a home increases by $1,000 in cost, we're displacing over 150,000 American families. You multiply that by about $30,000, which is the increase in cost in lumber today, and you can really see how bad the problem is. So we also believe one solution, not the only solution, but one solution is using 3D printing technology to save cost. We believe we can get up to 30% savings versus traditional building. We are not there today. We are in the ballpark of 5 to 10% today in savings. But we believe in the next 2 to 3 years, we will get to that 30% savings that we're shooting for. So we created Alquist 3D specifically to address these issues that we're seeing in every community that we work in across the country. We believe heavily in community. Each community we have will have its own very unique features that reflects the local culture. Affordability is a strong belief. We believe a house is a home well before it's an asset. We believe in sustainability, much like what Sam was talking about. We're working on many of the same concerns as well. And then technology, not just in the creation of the home itself, but far beyond, which I'll talk about in a moment. So inventory for homes for sale have been at historical lows. We know this. We see it all the time. The costs keep rising. We just surpassed $400,000 as the median home price in America, which displaces many people in the country, especially in rural areas. And thanks to some interesting data from Zillow, many people would rather be going on Zillow than doing other things, especially this last statistic there at the bottom, which I'll just leave there for you to read. So people are doing whatever they want to be doing, and they're rather looking at Zillow than some other things. And here's what's interesting, is that 3D printing is not necessarily new. This is footage from 1934 that we found of the people using very similar technology that we use today to 3D print with concrete. Of course, we're not standing there on a scaffold dumping the material directly into the machine, and we can move much faster than this machine is moving. But the basic tenets of this are the same. Now, we do attain very much, if there's one thing we can learn from this video, we very much want to have the choreography that these guys have here at the end. And we want to be able to do this at the conclusion of all of our homes, but we haven't quite achieved that just yet. So our first home that we finished was in partnership with Habitat for Humanity. This was in Williamsburg, Virginia. This became the first ever 3D printed home in the world to have a family living in it. That was not our goal. We got lucky there in timing, but it did become that home, and we had such a good time printing that. This is the home itself. It is a 1,300 square foot, 3-bed, 2-bath, single-story slab-on-grade home. We 3D printed the exterior walls only. We smoothed the print, the concrete, as we printed it. And so it has almost a stucco-like look. And then we gave it 2 coats of white paint. And that's about it. The rest of the home was built out traditionally the same way you would build any other home. On the inside, the homeowner chose to cover up the concrete with drywall. And so you would never even know this home was 3D printed when you go inside. We don't always do that. You can certainly leave the concrete bare, which of course saves cost, but you can also put up the drywall like April decided to do. Here's a little bit of footage of the exterior walls of that home being printed.
It's a beautiful day. We couldn't have done any better. I know. Again, we must be good luck.
So what you're seeing here are the exterior wall being printed. We print 2 whites on the exterior, roughly 2 inches wide, with a 4-inch gap. Inside that gap is where we insulate, very similar to what Sam was showing. We do add some ladders, steel ladders, every 10 to 12 layers for reinforcement. The house, so some facts about the Williamsburg home. It took us 22 hours to 3D print the exterior walls. That was over a week and a half due to weather issues, and we keep getting better at that. It's estimated that it takes, the savings were about 10 to 15% per square foot. Normally, it would have taken Habitat anywhere from 2 more weeks to frame out the home than it did for us. The home is Earthcraft certified. We put Raspberry Pi sensor systems inside every wall to prevent damage, and also to be your security system for the home and your air quality system for the home as well. This home will be outfitted with a solar panel, a battery, and an EV charger so that we can hit carbon net level as we get forward. So that home was printed using a Cobod BOD 2.5 printer. We have a new printer from Black Buffalo that is our new partner that we're working with. This is that printer there. This printer is capable of going up 3 stories. We have not done that yet. We've only gone up 1. And it's on a track system. So we can lay multiple tracks and print multiple homes at a time. So this is a prototype print that we did about 3 weeks ago in Pulaski, Virginia. So we're not smoothing the concrete here. We were able to get really beautiful lines, which is what we wanted to hit with this printer here. You can see the footprint and the size of this thing. It doesn't even have the 2 extensions on the top to go 3 stories. But it is a beast. We love it. And Black Buffalo is working on even new printers that are smaller and easier to set up and break down that are coming out later this summer. So here's a couple advantages about 3D that we know. First of all, your cost savings come in time. We can reduce the home framing by about 2 to 4 weeks. Labor, you can only need 2 humans to operate the printer. We're not there yet today. We're still using 4 to 5. We're going to be getting down to 2 over the next 2 years. Part of the problem is there's no training system or program nationally that teaches people how to do that, which I'll come back to. And the material cost is far less than lumber today. When you add all that up, you get about 5 to 10% savings today. We believe we can get up to 30% over the next 2 years as we continue to gain experience. We also know that a 3D concrete home, even before you put a solar panel or other alternative energy on there, saves 50% less energy than a traditional home. So you're cutting your utility bill in half right off the bat. We have 80% less waste on site. The design flexibility is stronger. We believe these homes will last up to 175 years. And then the durability of the homes, which still needs a little bit more research, and we're really excited that Sam's doing that and other groups are as well. But we believe these homes can survive tornadoes, hurricanes, flooding, fire, and seismic shifts as well in the locations where we're going to be. And it's really important to note that the only difference between one of our homes and a traditional stick-built homes are our exterior walls are built out of concrete instead of wood. That's it. The rest of the home is still built out exactly the same as any other traditional home would be, utilizing electricians and plumbers, etc. And so we're able to pass all state codes wherever we're printing. So it's important also to note that when you think about a 3D concrete home, your mind conjures up all sorts of shapes and sizes and futuristic images. And certainly we can do that. And we've got lots of those designs. But for the first homes, we wanted to make sure that these look like home, any other home that would fit into the neighborhood that we're going into. So we came up with a very traditional floor plan to be part of that. The way that the process works, you use CAD software to design it. That goes into your surface modeling and into the software that talks to the printer itself. We mix all of our concrete on site. It's pumped through a hose and it lays out the walls layer after layer. We received lots of great press for this work all over the world. It was pretty phenomenal and overwhelming for how many folks contacted us about it, which is really exciting. And I want to take a moment and talk about why we're called Alquist. My background is in theater, so it makes total sense that now I run a construction company. But the Alquist is a character from a 1920 Czechoslovakian play called RUR that many folks have not heard of before. RUR is the first piece of literature that ever coined the term robot. This is where robot comes from. And the plot of the show is similar to any other science fiction book or movie you've read or seen. Man invents robot to speed up manufacturing. Robots learn about their surroundings. They don't like how they're being treated and they revolt and they kill all the humans. Spoiler alert. But there's one character named Alquist who's a lead engineer who believes that robots and humans can coexist together peacefully. And he is spared by the robots and charged with rebooting the human race. So that's the play. But we're named Alquist after that character to remind us that, yes, we are using automation to replace human jobs with robots. There's no way around it. We have to own that. So we have a robust workforce development program that we're working on with Virginia Tech through a HUD grant that we're going to be offering this certificate program in 3D CP training starting next year at community colleges and high schools everywhere where we're going to be printing. So we have a great new workforce development program that we're building out. It should be a 6 to 8 week course, 3 to 4 weeks in the classroom, 3 to 4 weeks in the field. And anybody can be certified in how to become a 3D concrete printer. And we want to start really young, right when kids are like under 10 years old on the job site. I'm kidding. These are my kids that are on the job site. So over the next couple of years, this is our map for where we'll be printing. The next 2 years, we're going to be printing in Virginia, North Carolina, Florida, and Iowa. And many other states have contacted us. We're talking to all those other states in yellow right now. It's been overwhelming with the amount of groups that have reached out. And we're now offering licensee programs for all the places that we can't get to. We just announced Project Virginia, which is a project of 200 3D printed homes throughout the Commonwealth of Virginia over the next 4 years. We're starting this project next month in Pulaski, Virginia, a town of about 8,000 people in rural Appalachia. We're printing 2 homes starting there next month. Then we're moving down to Roanoke, and we're going to be several other places throughout the Virginia this year. We're still experimenting this year, and next year we're going to get much more robust, looking to print 50 to 100 homes next year throughout Virginia. We've got several strategic partnerships. We work closely with Atlas Community Studio, which is our other group that we started 10 years ago. Atlas does strategic planning, economic development, and creative placemaking throughout the country. We're working in 27 different states today. So there's a map of where we've been working. We specialize in master planning and revitalizing these communities, but housing is the #1 issue everywhere we go. So we work with Atlas to help us on the ground in the community, and then Alquist comes in to do the build. We're partnering with Black Buffalo. They are our printer manufacturer and material supplier. Mavericks Microgrids makes our solar panels, batteries, and EV chargers for all of our homes. We're also working with the National Building Museum on a big piece for next year, which we're really excited about. And we've committed to Habitat for Humanity in Williamsburg to print at least 1 home every single year with the group that we printed with last year. So finally, where we see ourselves going in the future, as I was saying before, historically, innovative people have taken their talents and ideas to big cities. That's all beginning to change. We can go anywhere if we have the right broadband and housing. We believe that 3D printing is going to make housing much easier and more affordable. We also believe in blending the worlds of printing prefabricated units like Sam is doing in a factory and printing on site. We think those 2 worlds are going to get married here in the next couple of years that we're looking forward to. We believe alternative energy is going to run its course and be everywhere throughout rural America coming soon. And we also think that there's a new approach to home design, renovation, and repair. Every Alquist home that we print and sell will come with your own personal 3D printer built into your kitchen, just like a microwave. And we're doing this, 1, to help stand up the industry, but 2, we think this is where things are going in the future. If you want to change anything inside the home, we want to be able to 3D print everything inside your home out of multiple materials, not just concrete. What you see the printer printing here is a light switch cover. This cost 17 cents to do. It took about 40 minutes to print. In the future, if something breaks or you want to change the look of something, you're not going to go to the hardware store. You're going to go online, you're going to download a file, and you're going to print it out yourself. And we want to be at the forefront of this new technology. We're also looking at using new materials, just like Sam is. We want to use recycled glass and plastic in our materials. We want to get into hempcrete. We're beginning that research right now. We just wrote an interesting grant in Appalachia to study whether we can use coal fly ash in our material. We don't know what the environmental impact of that will be yet. And so we're beginning that work now with our university partners to figure that out. 15 million Americans are on the move by 2023 and 2024. If your community needs to grow, now is the time to wave your hands in the air and say people need to come to you, but it means you must have the right housing and broadband to support it. These are just a handful of the communities I've been to in the last year. And if there's any great unifier that I can offer, it's that whether you're in rural New Hampshire, rural Arizona, or rural Kansas, we all have the same problems. Housing is the #1 issue everywhere that we're going. And that is a great unifier. And I want to close with this quote from one of my mentors, Richard Florida, who says, "The remote work revolution promises to change the way that Americans work and live. It will allow smaller cities, suburbs, and rural areas to compete with the superstar cities on the basis of price and amenities. It will shift the main thrust of economic development from paying incentives to big employers to investing in building up a community's quality of life. As communities attract more remote workers, their tax bases will grow, allowing them to improve schools and public services, benefiting everyone. Eventually, companies will come too. That holds out the possibility of a better, virtuous circle of economic development. I could not agree more. This is exactly what our mission is. And thank you so much for your time today. It's an honor to be with my colleagues here."
Thank you so much, Zach. I love the presentation. I love every second of it. And we have a couple of questions, so we're going to ask you at the end. So our next speaker is Luway. Luway Qardi is joining us from Czech. Luway Qardi is the founder and CEO of PRINT4D. He's an architect and a 3D concrete printing expert. He's been working full-time utilizing this technology for more than 3.5 years. His startup company revolutionizes by reducing the amount of concrete needed to build structures, reducing the CO2 footprint, and also eliminating waste in construction projects. He has been working on multiple applications in construction, from small-scale projects such as infrastructure projects to large-scale projects such as fully printed buildings. Thanks so much, Luway, for joining us, and I'll let you talk more about your work.
Thank you, Niknaz, for the invitation, and it's a pleasure to be here with everyone. All right, I'll just go ahead and share my screen. Just a kind confirmation if you can see my presentation.
Yes.
Perfect. So hi, everyone. This is Luway from PRINT4D. I'm the founder and CEO. And at PRINT4D, we're revolutionizing construction with cutting-edge technology. Our technology relies on robotic-arm 3D concrete printing, where we are focused on prefabrication and off-site manufacturing for houses and other applications in the concrete industry. I have this case study to share with you, which is actually the first fully structural load-bearing building in the UAE, where we did not use any steel reinforcement. This project is located in Abu Dhabi, and it was constructed around 1.5 years. So as I mentioned, it's a prefabricated offsite construction methodology, and I was very fortunate to be the architect leading this design and project, and also the 3D concrete printing expert who printed the project. Having the background in architecture and construction, I really tried to figure out the small details and the challenges and try to innovate on them in this project, and I will be sharing more with you during the presentation. So I'll start with the technology highlights with 3D concrete printing technology. Of course, with this technology, we're able to have much more freedom in design, and basically it introduces a new architectural language that we were not familiar with, or that we were not able to achieve in this kind of ease, because with 3D concrete printing, both these structures that actually I designed, and the majority of the designs that you will see in this presentation, I designed myself and printed. All of that I did during my work in Dubai while I was working for B6. So with this technology, if you want to design these really complex, double-curved, interesting organic geometries, you don't have to use any molds. Then you are saving a lot in terms of the material, because you don't have waste material. And also in terms of lead time, you basically take it from your 3D software into the printer and you start printing. So there is no real gap between that process. In addition, the technology is a fully digital one, and it's an automated one. On the left hand side, you can see this picture of the printer printing this wall, which is the woven wall. And basically, I'm just taking pictures, walking around and not really doing anything. Very minimal supervision. It only takes one person to operate. And we work with BIM models. It's very important for us when we constructed that building in Abu Dhabi is to have a fully coordinated BIM model, meaning that we need to understand how the architecture works with the structure, how it works with the MEP, how it works with the other services in the building. So when we start the printing, we know that we don't have any clashes and we can have a seamless project. Here on the right side, you will see a small video demo of the printed modules being assembled on site. What we do is we print both exterior walls and interior walls, so mainly the full building. And we work on both, a fully load-bearing system like the one that I'm showing you on the left-hand side. That building we used 78 modules, and all of these modules are unique, and we ship them basically from Dubai to Abu Dhabi. It's a 1 hour trip with the truck. We laid down the pieces next to the final concrete slab foundation, and we started to install one piece at a time to get the final look that you see here in the picture. And if you look closely, you will see between the modules, you have a very or maybe it's a better way to say it, you have a lighter white line joining the pieces. And basically this is the joint horizontally. And then vertically you have the joints that are apparent here. And on the right-hand side, it's also one thing that I get asked a lot is that, we are printing one layer at a time. Does that mean that we have a monolithic structure at the end? And the answer is yes. But that does not mean that we have the same structural properties in all directions with this methodology. Going to the architecture, the features and solutions that we worked on in this project. So this is a fully structural load-bearing system. It means that all of the walls, the 3D concrete printed material itself is carrying the load of the roof. So we don't have any steel inside. We don't have any traditional columns inside, which means that this is a more, classical approach to construction. And you can see here both the front view and the back view. This is what I mentioned earlier about the fully coordinated BIM model. So here you can see that we had all of the fixtures, sanitary, mechanical, electrical, plumbing, piping, electricity, all of the fixtures fully coordinated and modeled in 3D before we even started printing. And once we knew that everything works seamlessly together, we went ahead and started printing. And what this opens up for in terms of architecture and construction is that it's a new way of building. We are fully printed. We are printing fully printed building blocks. So if you look on the left-hand side, this is the facade. Obviously, it can be as artistic as you want. And on the right-hand side, you can see the building section assembly. And what I mean by that is that on the exterior, you have the facade. Then behind that, you have an insulation cavity where we use PU foam insulation that expands inside. We have a structural infill. And then you have the interior wall of the building. So with this technology, you're able to print all of these components at the same time and ship them for final assembly. Compared to traditional manufacturing, where you need to actually assemble one piece on top of the other. So you will need to assemble the insulation on the wall, then you need to install the facade on the insulation, then you need to finish the interior wall. But here, no, you do all of that in one go, and that's the real speed and innovation that this technology offers. Some of the architectural challenges, for this project, there are a lot, but because we're limited with the time, I only mentioned a few. So, as the architect designing this building, I really wanted a neat and clean vertical joint throughout the whole building to make it really look nice and minimal. So on the left-hand side, you see Project Milestone that was printed in the Netherlands, and they used a more traditional solution for the lintel. So you would see the lintel basically, for you who don't really know what it means, the lintel is the structural component on top of the opening. So here you can see the main door opening. It has the lintel on top of it that sits on both sides on top of columns. So this is the way how it's structurally supported. But we didn't want to do that. We didn't want to take the easy way. We wanted to innovate and introduce a new way of architecture. So the solution that we came up with is that what if we try and suspend the lintel on the roof structure? And this is what we actually did. So if you look at the detail on the right side, top right side, we actually suspended the lintel. So it's basically flying on the air without being supported from the bottom. So this is one of the innovations, and of course the technology allows for it. In addition, I tried by doing the design to fully utilize the technology's advantages. So I made sure that there are no vertical walls on the exterior. So if you look at the photos, all of the exterior facades are inclined in different angles. Of course, this has a really nice effect with the sun changing during the day, the reflection of the light and the textures changing. But also it brings a new type of architecture that I was talking about before. In terms of speed for this project, so it took us 3 weeks to print offsite in a 3D printing factory. And it took us 4 weeks to do the assembly on site and the final finishing. We did not need to do any additional plastering or finishing. The work on site and the work off site were taking place in parallel. It means that we can really accelerate on both ends without one having an effect on the other. We had a very small team on site during the installation, and also small footprint because we only had a mobile crane, basically, a storage site where we stored the printed modules, and then we were assembling them one by one. So I'm going to talk about a topic that is basically robotic arm versus gantry. And the reason I chose to speak about this topic is I get a lot of questions from people like, why robotic arm, why gantry, so on and so forth. Obviously, I work with robotic arm technology, so I have my own preference. But that does not mean that I completely oppose the gantry system or anything. But I personally prefer the robotic arm, and I see many advantages that I will share with you in the next slides. So for you guys who are not really familiar with the gantry term or robotic arm term, so on the right-hand side, you have the robotic arm printer, and on the left-hand side, you have the gantry printer. I will start talking about in terms of downtime. So if we compare the downtime between the two technologies, with the gantry printer, you will need to transport the frames, the foundations that you will need to install on site. You're going to have to assemble them. You need to do the calibration before you start printing. And after you start printing and you want to go to the next project, you'll need to disassemble the whole printer and start all over again. So there's a lot of time invested and labor in assembling, disassembly, and transportation. Whereas with 3D, with the robotic arm printer and the offsite manufacturing technology, there is no downtime. Basically, your printer is fixed. It can work day and night. So we have much higher productivity. In terms of printing quality, with the gantry system, you see the photo on the left side is the house printed in Germany. And basically, because you're printing outdoors, you don't really have control over the environmental conditions. So one day you can arrive, the temperature is 5 degrees Celsius. The other day it can be 10 degrees Celsius. And actually, this is quite a big headache for operating this technology, especially because the materials are usually sensitive to the environmental conditions. In addition, you would need to have a tent to cover the printer and during the rainy weather. So imagine having all of the work and the labor and time invested in that, of course, and its implication on the cost. In addition, it's very difficult to print during cold winter and hot summer conditions because you don't basically have a lot of control on the material quality. Whereas with the robotic arm printing technology, and because we are doing offsite manufacturing, we're printing indoors, we have full control over the printing conditions. So we can really fine-tune it to the right parameters. And because of that, we achieve higher quality control standards. In terms of print quality and resolution, with the gantry printer, there's also other limitations such as, you can only do simple vertical surfaces. This is, of course, because you're using thicker and higher layers. There's a small turn radius for the print head, which is also a bit less accurate, I would say. And that is the reason behind that is because you have high vibrations due to the scale and weight of the frame of the printer. So typically doing strong turns is a little bit not the way that the printer likes to go. And in addition, because of this less accuracy and the lower quality of printing, you need to do plastering, painting, and finishing. So all of the traditional things that can be avoided, it still needs to be done here. And the last point is that if you have any failure during the printing on site with the gantry printer, you can't simply say, okay, I'll remove this section and just start printing again. It just doesn't work like that. So you'll have to accumulate it on top of each other and try to finish it later on when the printing is done. However, on the robotic arm printing, on the right-hand side, you can see the quality. We are able to produce complex double curved surfaces because our print accuracy is plus minus 0.05 millimeters. Basically, that means it's 100% accurate, the process. And we can leave these beautiful layers as a final finish. We don't really need to leave them. It becomes as a personal preference for our clients. And then if you have a failed module, which often happens to us, you can easily reprint that piece. You don't really need to reprint the whole project. Of course, I don't, by making these comparisons, I don't mean to say that the gantry system or technology is not good or it doesn't have advantages. It does, but of course, it has in certain categories and certain applications and certain weather conditions. So if you manage to find the right city that has a quite stable environmental conditions throughout the years, maybe it would make sense. But in fluctuating weather, it's quite difficult. In terms of 3D concrete printing and traditional, in terms of price, I'm going to start with price. Because it's a proprietary mix, this 3D concrete printing mix is 6 to 8 times more expensive than traditional concrete, which is one of the factors that don't help the technology. And that's why some of the printed projects are still not competitive enough with traditional methods. But on the other hand, we have very exciting new developments, as the photos on the right-hand side can show, where this has been printed by Tolke, HSH, in Germany, where they're basically using normal concrete straight from the truck to print, which is a really nice advancement. You would need to use some additives to make it printable, but still, with this approach, you're able to reach 1 to 1.5 the times of the normal concrete mix. In terms of time and speed, with the old methods or the traditional methods, it's obviously much slower. You have to build, of course, now I'm comparing concrete to concrete. So you have to build one block at a time, as you can see in the photo. You have a large construction team, and there is big room for human error. However, with the robotic 3D concrete printing, you are 6 times faster than traditional concrete methods. We have a continuous fast speed printing. We're printing on average 15 centimeters per second. We have very short lead times. If you have the model ready, you can start printing directly tomorrow. You don't need to wait for any molds, for any special components. And you only need a single printer, which does not produce any errors. Also, what we're working on in Print4D is the topic of green and sustainability, because we don't really believe that traditional concrete is the building material of the future. So we're working on 2 aspects to reduce the reliance on concrete and therefore to lower our CO2 footprint and emissions. So on the left-hand side, you can see the structural optimization that we can achieve. So if you compare a traditionally cast concrete wall, which has 100% infill, to the walls that we're able to print, which basically have the same structural performance, we're able to save 55% of concrete material with this technology. In addition, we're trying to develop the concrete mix itself. So we're trying to develop lower cement mixes that helps, of course, to lower the CO2 emissions. And we're also introducing recycled and waste materials that will ultimately help reduce 50% CO2 emissions. So combining those 2 approaches, we are able to reduce the CO2 emissions associated with concrete manufacturing by up to 75%. So this is very exciting news, and we're happy to be part of this.
Great, thank you so much, Luway. We are getting close on time, so
okay. So I'll just wrap up.
Oh, sure.
I'll just wrap up. So I'll skip some of these slides maybe and just go to the last 2 slides, which is our future plans.
Oh, sure.
We have, what we're thinking about the technology is that we're going towards something that we like to call the factory of the future, where we have a factory of multi-process robotics. We do the 3D concrete printing, CNC finishing, the installation, and the MEP integration in one assembly line. And we're also at the same time working to develop mobile print factories in 40-foot shipping containers, where you can basically ship it and print anywhere on the site. Thank you so much, and sorry for being too long.
Wonderful. No worries. Thank you. Love the presentation. Very informative. Beautiful projects, beautiful designs, sophisticated construction. So, it's fascinating how you all are working on these exciting projects, and you are all working in different climate zones. So we have a number of very good questions. I'm afraid that we cannot address all of them, but I'm just gonna ask a couple of them that are related to you guys working in different climate zones. So Ramoon, apologies if I'm pronouncing your name wrong, is asking for insulation. So how you guys add the insulation to the building, what material you use. And Malik is also asking about the compressive strength of the materials that you use for your buildings. And then I'm just going to add one more to this mix. Jennifer is asking if you use hempcrete in your sustainability efforts. So maybe Sam, if you want to answer first, Zach and Luway. So we have 5-6 more minutes, and then maybe we can address a few more questions. Really quick.
Yeah, happy to, and I'll try and be quick so we can keep moving. So yeah, currently we pour polyurethane foam insulation into the interior cavities, and we're actively working with our suppliers on more sustainable variations of that, whether that's algae-based polyols, soy-based polyols, and other alternative blowers. So we're actively working to accelerate that, as well as increasing the R values. And as that adjusts for climate, we can just go to thicker walls for areas where we need additional insulation. In terms of compressive strength, I don't have the exact number off the top of my head, but it exceeds code by, I believe, at least 3x, since we build a 3x safety buffer into all of our design and production. And we are not currently using hempcrete, though we are looking at hemp wool and other opportunities for hemp-based installations, largely because we are not printing with concrete. Though for foundations, we are looking at low and carbon negative concrete, utilizing some of the tools developed by Brightworks, Carbon Cure, Blue Planet, and others.
Wonderful. Thanks so much, Zach.
Almost identical to what Sam just said. I would just say that we use closed cell spray foam insulation right now, but we'd like to use something much more sustainable. That's what we're experimenting with. The concrete we're using from Black Buffalo is approximately 7,500 PSI. And we are looking into greener methods all the time. We're not using hempcrete today, but the moment that it is proven, we will be.
Wonderful. Great. Thank you. Luway? I think you're muted.
I think you
Luway.
muted.
We cannot hear you. Yeah.
Yeah, I was saying that we actually use the same material, PU foam insulation, and the reason being is because our geometries are not vertical and not regular, so foam expands and it's really easy to fill the cavities. In terms of material, we don't use hempcrete, but we are steering more towards a more sustainable and green concrete mix that has less CO2 impact on the environment.
Great, thanks. So Rami is asking what the variables are for understanding which climate zones these methods would work best in.
Yeah, so we designed ours initially for California, but one of the cool things about California is it has a lot of climate zones, everything from Death Valley to Tahoe. So that's one of the reasons we picked here, along with the incredibly stringent environmental standards and stringent building code in terms of seismic, fire, all those other elements. So for us, it's really about understanding what the necessary R value is to achieve the energy efficiency standards that we have for ourselves. And again, that can be adjusted for by shifting the thickness of the walls pretty easily, and also looking at higher density foams or higher R value foams that allow us to maintain the energy efficiency and while having a thinner wall.
Great, thank you.
Oh, and snow
Zach,
levels.
how about you? Oh, okay. Awesome. Thank you. So Zachary, how about you? And then,
yeah, I mean, we printed in Virginia so far. We're going to be printing in other states. Because we're printing on site, it's a complete variable every day. And as the others have said, there is a definite advantage to printing in a controlled environment. So we're looking at both right now.
Great, thank you. Luway, how about you?
Yeah, our material currently, the one we're using, has a compressive strength of 50 megapascal and a fluxural strength of 6 megapascal. And as Sam mentioned, to increase the insulation performance of the building, you simply increase the thickness to add more insulation. But also what we're using with our concrete printing technology is the thermal mass of the same concrete material.
Awesome, great. One more question. Nathaniel is asking about the use of alternative concrete options in the future.
Well, I'll pass it over to Zach and Luway, since that's more their area.
I mean, there's a lot of different options to you. We're still experimenting. We're really at the beginning of this industry. Is something that we need to be paying attention to. So we need more academic partners to be taking these projects on and doing these studies. So I would simply say that over the next 2 years, you're going to see more and more options.
Great. Luway, what do you think?
Yeah, I mean, there's a lot of things happening in Europe in terms of development of the material to make it more green and sustainable, especially in the universities. And it's just a matter of time. At the moment, we as an industry, we're trying to take the input and the lessons learned to try to implement it in our projects. But of course, there's a lot of testing that needs to be done before we start using it on actual projects. But it's just a matter of time. I mean, the technology is there. The material has been tested in the small scale labs, and it's just a matter of time before we make that switch.
Great. Great. Thank you so much, everyone. I'm sorry that we don't have time to address all the questions, but I encourage our dear audience to reach out to our dear speakers and ask their questions directly. So we have a number of them, but unfortunately, we're at time. So thanks again. This event will be recorded and saved on our YouTube channel. And I hope you have a great weekend and a wonderful rest of the day.
Thanks everyone. Have wonderful weekends and take care.